Now, we will pick up on the discussion that we had on the first part of this video, in which, in this case now, we are now ready to determine the output sequence, okay, or the response of LTI systems when we feed it with an arbitrary input, okay. The algorithm that we will be studying in this at this point is what we will call the convolution sum. And I know that you have heard of the convolution sum before, especially in your advanced engineering mathematics course, at napag-usapan yan sa part ng Laplace transform. Okay. That convolution sum, this convolution sum, the algorithm for this convolution sum is actually yung discrete time counterpart nung convolution sum dun sa pinag-uusapan sa advanced math ninyo. So again, if you would try to make sense of this things, pag nag-aral kayo again ng signals and systems, pinag-aaralan lang siya on the perspective na you have a continuous time system having continuous inputs and producing continuous outputs. Okay, o kaya meron kang discrete time system na you feed it with discrete time inputs and it produces an output of discrete time sequences. Okay, so ibig sabihin, the algorithms, okay, and the representations and everything, the mathematical tools can be actually divided, okay, into tools that deal with continuous functions or continuous time functions, okay, at saka yung mga discrete time tools, yung mga tools that are used for discrete time functions, okay. So yun, so yung convolution sum that we will be talking here is actually the discrete time form, okay. This is a discrete time form of the convolution sum. Okay, so of the convolution sum, okay. So saan natin gagamitin ang convolution sum, okay. Ito kasi yung hindi natin diniscuss with this is something that we haven't discussed in your previous at hindi niyo malamang hindi niyo discuss dun sa advanced math niyo, Ang convolution sum actually, okay, is used to determine the the response. This is on the perspective or on the standpoint of system analysis. Kasi pinag-aaralan natin ang convolution sum sa advanced math as a mathematical tool lang. Okay. For example, ginagamit natin siya to evaluate yung Laplace transform or inverse Laplace transform ng ibang mga functions natin. Okay. But on the standpoint of signal analysis, okay, ang talagang purpose ng convolution sum is to determine the response of a system, okay, given certain characteristics or certain representation of the system. Yeah, may kulang ako sa sinabi ko. Determine the response of a system given certain representation or characteristics of the system and the input. So the input to be fed to the system. Sa continuous time system. Okay. Actually, pareho lang naman yung terms na ginagamit natin sa continuous saka sa discrete time. So sa continuous time system, kapag ang system ninyo continuous time system, okay, pag ang system ninyo is described by what we call the impulse response, h of t is considered the impulse response in continuous time. So, ibig sabihin ng h of t ninyo is a continuous function. So, ht is continuous time function. Okay? So, pag may input kayo dyan na x of t, Okay? At may output si ano niyo, si system niyo ng y of t. Then you can find y of t. Okay? As the convolution sum. Okay? Which is the integral of x tau, h of t minus tau, d tau, from, I think this is this is from 0 to t. Okay? This is from 0 to tau equals t. Kasi ang variable of integration natin dito is tau. Okay? So, ganyan yung yung continuous form ng convolution sum ninyo. Okay? Ngayon, sa discrete time, yun yung i-define natin actually ngayon dito. Pero essentially, ganoon pa rin, no? Yung system ninyo is being described by its impulse response, h of n. And now, in this case, your h of n, still, okay, both of them tawag dyan, whether you call it in continuous time or discrete time, both of them are called impulse response. Okay? And both of them are actually defined in the same manner. Ang pagkakaiba lang talaga nila is kung paano kung paano na-generate yung impulse response using the continuous form ng delta t. Ito naman, paano na-generate to ng delta n. And of course, kung tutusin, medyo mas madali itong part ng discrete time side natin. Okay? So, ayun. But in any case, pareho lang yung essential yung fundamental principles na ginagamit natin diyan. Okay? So, in this case, tawag sa kanya parehong impulse response. Okay? And ht here is continuous time function. Ito, yung hn natin is actually a discrete time function. Okay? So, again, makukuha natin yung output sequence y of n, a discrete time signal, if we feed this system, okay, being described by h of n, okay, if we feed this system with x of n, okay, so yan yung essence ng convolution sum. So convolution sum exists para sa continuous time at saka discrete time, at ganyan yung pinaka-purpose ng algorithm na yun. Okay. Now, in this case, since we're talking about discrete time, okay, we will use that to compute or to determine the response, the output sequence. Okay, the response here is the output sequence y of n. Okay, so for a relaxed LTI system, okay, so ito isa pang i-emphasize natin ito. So again, LTI systems are described, okay, can be described pala by h of n, by the impulse response. Okay, and you can only use the convolution sum, okay, if that LTI system is relaxed. Okay, what do we mean by relaxed? Okay, anong ibig sabihin natin sa relaxed system? We take note that that your system, okay, that your LTI system, na-recognize natin ito before. Okay, na-recognize ito before. That your system has memories. May memory yung system niyo. So, kung maalala nyo, kina-classify natin or kina-characterize natin our system as either static or dynamic. Okay? So, actually, whether it's static or dynamic, merong memory yan. Okay? Meron yung certain kind of memory. Okay? And that memory of your system, okay, sa standpoint ng algorithm, kasi sa algorithm, we call it as the system state, the state of the system. Okay, meaning these are internal stuff about your system, okay, which is kept on the system's memory. Okay, pero yung memory kasi is minsan is used to describe yung hardware component nung ninyo. Okay? But whether you're talking about the hardware or the algorithm collectively tatawagin natin siyang memory. Okay? Pag gumagawa rin naman kayo ng for example ng code. Okay? At especially kapag kayo ay naglo-loop, for example, may mga times na you have to save your to save one part of your calculation in a variable. So yung ganung practice is actually saving a value to a memory. Okay, so yung variable na yun is a memory location, okay, which is actually a physical memory location din. Okay? So, yun yung aanahin natin. Now, when you say a system is relaxed, okay? Itong memory or yung system state yung state ng system niyo is considered or in a mathematical standpoint naman kasi ito sa hardware standpoint ito naman sa algorithm. Sa mathematical standpoint tawag natin diyan initial conditions. Okay? So, initial conditions yung tawag natin dun sa mga yan. Okay? So whether we call it as the initial condition or the state of the memory or state of the system, okay? A system is relaxed if if these things, the initial conditions, the memory, okay, or the system state is considered to be 0. So, sa mathematical standpoint, yung initial conditions yung 0. Okay? Sa memory standpoint or sa state standpoint, it means na walang nakasave or walang nakasave dun sa system niyo. Okay? So when that is the case, okay, we can consider the system to be relaxed. Okay? And again, remember that you can only apply the convolution sum, okay, to find the output for a system or to find the response of a system given an arbitrary input kapag relaxed yung system niyo. Okay? So ano 'yon? Dapat inherent na kagad sa atin 'yon. Okay? Na we will have to look for the initial conditions or the state of your system or the state of your memory pagka magko-compute tayo ng output using the convolution sum, which dapat naka-state dapat na relax siya or 0 siya. Okay? So, again, we will use the HN, the impulse response, okay, as the way to find this response or this YN. Okay? So, just remember then, additional information about the impulse response is that the impulse response characterizes the LTI system. Okay? Characterizes dahil later on, gagamitin natin ang impulse response to further describe or to further put into perspective yung yung characteristics ng system niyo. Ano pa yung masasabi natin sa kanya? Okay, so ayun. And aside from characterizing your LTI system, it also allows for the computation of the output sequence. Okay? Yun na, yung output sequence YN. Okay? Produced by the system, okay, in response to an arbitrary input sequence. So, yung arbitrary input sequence natin, yun yung X of n. Okay? Now, the formula, okay, that gives the response YN of the LTI system as a function of the input signal Xn and the unit impulse response Hn is called the convolution sum. Okay? And that formula is this. Okay? So, yan yung parang pinaka-formula nung convolution sum natin. Now, actually, we would not be remembering sa case ng discrete time systems at sa pag-aaral natin ng discrete time systems. We would not be actually remembering, okay, this formula as the formula for the convolution sum. We will actually remember this more of as an algorithm. So kailangan mas matandaan natin siya in terms of the algorithm rather than the formula itself. Okay? So kumbaga, we should recognize the form of the formula or the look of the formula. But when we are to use this formula to actually determine y of n, we will be remembering more of the steps involved in the formula rather than the formula itself. So, here are the these are some of the terms that we will have to use. In this formula, we say that xn is convolved with hn. Or we also say that yn, ito rin yung term na here, we can use this phrase para to describe equation 3. Xn is convolved with hn to produce y of n. Yan, isang phrase na applicable yan dun sa equation 3. Okay, also we can say that y of n is the convolution sum of xn and hn. So these two phrases are correct ways of reading equation 3. Okay? So ayun. And yung mga derivatives ng mga phrases na yan. Okay. So ano yung operations? What are the operations involved in the convolution sum or in the algorithm of obtaining the convolution sum of two sequences? Okay? So the first one is folding. So here, based dito, okay, ang output index kasi natin is n, okay? So, our output has an index of n, okay? So therefore, it means that if you are to substitute anything inside this summation formula, okay, you would have to replace n with k. Okay, papalitan mo lahat ng substitute natin sa loob ng formula na to, okay, has to be replaced with k. Lahat ng n has to be replaced with k. So substitution into 3, okay, requires replacement of the variable n with k. So lahat ng n, okay, ibig sabihin pag nagsubstitute kayo ng x of n dito, lahat ng n nung x of n gagawin yung k, so that it becomes x of k. Okay? So same thing with h of n. H of n. If you substitute h of n here, okay, you have to replace all the n's. Okay? All the n's of h, okay, into k's. Okay? Now what would happen is that so yung h of n niyo, yun yung magiging h of k. Now the first step, what you would do after that is you fold now your h of k. So that's the first step in the algorithm. So you fold now h of k, okay, about k equals 0, okay, to obtain the time reverse or the time folded version of h of k. Okay, so that's the first. Okay, now next step in the algorithm is shifting. Okay, now yung folded h of k niyo, which is now h of negative k, has to be shifted by n of 0. Okay, I'll explain the significance of n of 0 later on. Okay, pero may importanteng role na i-play yung value ng n of 0 sa algorithm natin. Okay, so there, this is the n of 0 here is the amount of shift to be done, okay, for h of negative k. Okay, so just remember that if tandaan natin to, since we will be shifting h of k by n0. Okay, so this becomes h of n0 minus k. Okay, we remember lang that if n0 is negative, okay, you're actually shifting your signal to the left. Okay, so kapag yung since this is time reverse this is a time reverse signal already. Okay, time reverse signal already ito. So, ibig sabihin, kapag shift nyo si time reverse signal with a negative shift, okay, with a negative amount of shift, okay, the signal values tend to go to the left. So, basically, kapag negative yung n of 0 nyo, the shifting is more of an advanced operation. Okay? So, the resulting h of no minus k is an advanced version of h of negative k. Okay? While, kapag naman positive yung no na yun natin, sinubstitute natin or shift natin, if we shift h of negative k with a positive amount of shift, okay, the sample values tend to go to the right, which means the sample values tend to be delayed. Okay? So, ayun. Tatandaan natin na kapag ang amount ng no natin is positive, okay, we shift the signal to the right, while if it is negative, we shift it to the left. Okay? So, ayun, nandito tayo sa h of no minus k. Now, bakit siya h no? Kasi yung yung n0 kasi na yan, it's actually a particular value. Okay? Which will actually determine later on na yan yung kino-compute nating sample value sa isang particular time index. So, say for example, if your no is actually, say for example, negative 6, you're actually computing for the value of y when n is equal to negative 6. Ito yung kino-compute nating sample value. Okay? So, yun yung parang pinaka-role na ipi-play nung n0 dito. Okay? So, ayun. Now, so after shifting your h of negative k, okay, with n0, okay, what you now do, okay, is to form the product sequence xk and the shifted time reversed version of your h. I-multiply natin si xk, okay, i-multiply si xk at saka yung shifted and time reversed then shifted h ninyo, okay, para mabuo natin tong product sequence na to. Okay? So, we'll call that product sequence as v of k. So, ayun. Remember that this product sequence now is a function of k. Kasi again, pag nasa loob tayo ng convolution algorithm, yung time index natin nagiging k instead of n. Although later on sa operation natin, hindi natin mapapansin hindi natin madidistinguish yung difference na yun kung nasang domain tayo. Okay? So, ayun. Then finally, once na mabuo niyo yung product sequence na xk and hno minus k, you'll add up the values of the product sequence. So lahat ng values ng product sequence to i-add nyo. Okay? Now the sum, okay? The sum would amount to the value of the output at time n equals no. So ito yung sinasabi ko kanina. Again, kung ano yung value ng no na ginamit nyo to shift your h, okay, that would actually determine kung anong time index or kung anong time index ng output ang kino-compute natin. What would be the time index of the output that we are computing? So say for example nga, if your no, the shift that you have used is negative 6, then you're computing for a value of negative 6. Okay? So that's the algorithm involved in the implementation of your convolution sum. So again, if you think about this on the algorithm standpoint, it might be sometimes confusing or something like okay, and you might be perplexed na i-implement ba namin sa MATLAB yan. Okay. Well, the good thing about this is that this is already implemented in the MATLAB, so we will just do some konting modification. Gagawa tayo ng konting modification dun sa built-in convolution function sa MATLAB, then we will be able to use this in the manner that we are trying to discuss. Okay, yung consistent siya sa discussion natin, yun. So there. So again, the four steps, okay, in the implementation of the algorithm of your convolution sum is folding, shifting, multiplication, and then summation. Ngayon, ulit-ulitin niyo yan actually. Especially itong 2 to 4. Okay? So, ang mangyari kasi diyan is that you would have to have the shift. Okay? You would have to have the shift from negative infinity, okay, to positive infinity. Kailangan yung shift nyo mag-amount from negative infinity up to positive infinity. Okay? So, that would be kasi that means that you are also computing the value of yung y of negative infinity, okay, hanggang y of positive infinity. And this applies to infinite length signals, okay? Actually, this applies to all, okay? Pero actually yung what we will do here is we will implement, okay, ito. So that dito. What we will do in this lesson is to implement the convolution sum, okay, on two finite duration sequences. So meaning meron kang xn that is finite duration, tapos may hn ka that is finite duration. We will find out how to implement the convolution sum sa ganyan. Okay? Sa ganyang setting. Okay? So, yan. By the way, this is one acceptable notation for your convolution sum. So, instead of actually writing the formula 3 every time that you are trying to say na ito yung convolution sum, this is actually a parang a more compact notation. Compact notation for the convolution sum. Okay? So, ayan. Ito yun actually. Nabanggit siya dito. So, ayan. So, we will implement the convolution sum on two finite duration sequences. So, titingnan natin kung ano yung magiging epekto niya. Or paano siya i-carry out. Okay? And actually, we will use this, discussion. Okay? Especially yung example 2. Okay? In order to demonstrate yung four steps ng algorithm. Okay. So, yun. Now, second, we will also implement the convolution sum on two infinite duration sequences. So, given naman now that your x of n is now infinite duration and your h of n is infinite duration, how do we now carry out, okay, or how do we now implement yung equation 3 para sa mga infinite duration sequences natin? Okay, so ayun, yan yung approach natin para mas maintindihan natin yung ating convolution sum algorithm. Okay, so in example 2, okay, let's discuss this example 2. We will perform the algorithm for the convolution sum. Parang mali to. Perform the algorithm or implement, actually, more of implement the algorithm for obtaining the convolution sum for two finite duration sequences. Again, pag sinabi yung finite duration sequences, given na meron kang x of n as a sequence, okay, meron yan length na, so yung length ng x natin, okay, is equal to, say, n1 or nx, layer na nx. Okay, while your second sequence, h of n, okay, would have a length of, so the length of h is n of h. So both of them are finite lengths or finite numbers. Okay? So, those are finite duration sequences. Okay. So, by the way, pansinin nyo rin dito that while h of n, emphasize ko lang ulit, h of n or the impulse response characterizes and describes Hn, I mean the system, okay? Describes the system. Fundamentally, it is still a sequence. So, tatandaan nyo na yung Hn natin is still a sequence. So, I'm treating, when we're talking about, the convolution sum, okay, we're actually treating Hn to be a sequence or a signal. So, tinitreat natin ngayon si Hn as a sequence or a signal, which means that, if it is a sequence or a signal, then we can apply yung basic operations. Or not just the basic, but all the operations that we have studied on signals. Okay, especially if you take a look at lesson 2.3, tama, or 2.2, simple manipulations on So may apply natin yung mga napag-aralan na rin doon. Okay, so and this is actually the beauty of the impulse response. Okay, so not only it is the impulse response not only deals with systems, okay, it actually is a signal. Okay, it actually can be considered, or fundamentally, it actually can be considered as a sequence or as a signal. So, yun yung dito, wonder nung to. Okay, so dito, let's suppose that we are given h of n as the sequence. So, we take note that the length of h here is ilang terms to? 1, 2, 3, 4, 5. So, ang length ng nh natin is 5. Okay? While here, ang xn natin, okay, has this many terms. 1, 2, 3, 4, 5, 6. So, yung length of x natin for nx is 6. Okay? So, if you want to compute the output sequence, okay, yn, of the system described by this, basta ganito yung problem. Pag nagkaroon kayo ng problem, nagkaroon tayo ng mga problems dito, ito yung problem statement. Visually na lang given a system, whose that is being described by the impulse response Hn, okay, what would be the output sequence Yn, okay, given a certain Xn. So, ito yung given ninyo, given ito, at saka ito. Ang tinatanong, ano yung Yn? Okay, so kapag ganun yung konteksto ng tanong, then ang solution natin is the use of convolution sum. Okay, so ito yung required. Okay, so yun. So here, we are trying to find Yn given ito yung Hn natin tsaka yung Xn natin. Okay, so ganito, we will apply, okay, we will apply the four-step algorithm. Okay? Again, that's folding, shifting, multiplication, and summation. Okay? So, medyo maliit lang itong palakihin natin siya. Kaya hindi ako masyadong worried na maliit yung natin, yung table natin, because alam ko may zoom naman eh. Okay, so now, we start with with substitution. Okay? So, we start with with substitution of of the given x and h. And now take note na yung index natin, the index now is in terms of k, not n. Okay? So ito yung sabi ko sa inyo na na once na gumawa tayo ng substitution dun sa equation 3, okay, your index variable, okay, changes from k to n. Okay, by the way, may mas malaking version nito dun sa dun sa files na pinrovide ko with you. So, take note na ito yung sequence xk niyo, tsaka yung hk niyo na sequence. Okay? So, I highlighted yung yung mga blue. Okay, yung mga blue na empty cells. These are zero values or zero sample values for x and k. Okay? So, let me just call xn or xk as x. Tapos yung hk or hn as h muna ngayon para masyado tayong para for brevity ba. Okay, so ayun na nga, in-input na nga natin siya so this would be your your x and this would be your di kita. Black siguro. Blue. Ito, tsaka to. Okay, so this would be your x and h. Now, the first step is to fold. Okay, so let's fold hn. So, kung ito yung hn ninyo, pag finold natin yan, itong value na to, since yan ay nasa k equals 2, mapupunta yan sa k equals -2. So, magta-time reverse siya. Okay, so again, review natin yung yung time reverse operation. So, yung value dito sa k equals 2, mapupunta sa k equals -2. So, kung -1 to, ayun, mapupunta siya doon. So, ito, yung value dito, mapupunta sa k equals -1. Yung value sa k equals 0 is still the same, sa k equals 0 pa rin. This one, yung value sa k equals -1, mapupunta sa k positive 1. Okay? And then yung sa k equals -2, mapupunta sa k equals positive 2. Okay? So, that's time reversal. Okay, so that's folding. Next, let's shifting. That's the next operation, shifting. Okay, so we start with with the folded with the folded h. Okay, so yung folded h natin ito. Kinopy natin dito. So yung folded h natin, ito siya. Okay. I-shift natin yung i-shift natin ngayon si folded h, okay, by a certain amount no or n0. Okay. So again, yung shift na yan sinasabi natin yung amount of shift na yan, okay, sorry. Yung amount ng shift na yan should be from negative infinity up to positive infinity. Okay, that should be the amount of shift. Okay? Medyo careful na ngayon. That should be the amount of shift na gagawin natin. Okay? But since we're dealing with finite duration signal. Okay? Since we're dealing with finite duration signal. At saka this is actually impractical naman in our case. We will simply just use some practical values for n0. Okay, which in this case, let's have it to be as -6 muna. Okay, so we'll shift it with we'll shift h, we'll shift folded h. Okay, we'll shift the folded h with -6. Okay, by -6 pala, by -6. So ibig sabihin nun, kung i-shift natin siya by -6, negative yung shift means it will move to the left. The signal values would the signal values of h, okay, would move to the left by 6 time indices. Okay, so from -2, okay, mag-shift yan ng 6 na times. So 1, 2, 3, 4, 5, 6. Doon siya mapupunta. Itong -1 na sample value to, mapupunta siya sa time index na -8. So ito yun. And everything else will follow. Okay, so ngayon itong signal yun na ngayon to, this signal now is referred to now as h of -6 minus k. So we will refer now to the shifted signal as h of -6 minus k. Okay? And still makikita nyo yung x of k ninyo nandito siya. The original x of k pa rin. Okay? So that's the second part of your algorithm. Okay? The third part. is multiplication. Now, what we will do is, yung shifted, yung shifted H natin, yung shifted folded H natin, okay, which is this one, okay, at saka yung X of K natin, which is this one, i-multiply natin yung dalawang sequences na yan. So, we will multiply H of negative 6 minus K with X of K. So that we will produce the product sequence V. Okay? We'll call it V negative 6. Okay? I'll call it as ano. Para ma-indicate natin kasi yung shift. Okay? So, V negative 6 of K. So, we'll call the product sequence as V negative 6 of K. Yan. So, yung product sequence na to is V negative 6 of K. So, i-multiply natin siya ngayon, no? So, this sequence, at saka itong sequence na to, i-multiply natin. But as you can see, okay, ito yun. Dito natin gagawin yung multiplication. As you can see, pag minultiply ko itong dalawang to, the non-zero values of, my sequence here, okay, coincides with the zero values of my signal xk. Okay? And in the same manner, yung non-zero values ng x ko, okay, coincides with the non-zero values, coincides with the zero values of h ko. Okay? Eh kapag binuo ko tong product sequence na to, i-multiply ko siya per signal value. Okay? So i-multiply ko to, for example, then ito, then ito, then ito, ito, and so on. So, ano mangyayari kapag binultiply ko siya at binuo ko yung product sequence na V? The product sequence would all have 0 as the sample values. So, all values of V negative 6 is 0. So, ganun yung mangyayari dito. Since yung non-zero nung HK, o yung non-zero values ng HK, coincides with the zero values of x, while the non-zero values of x coincides with the zero values of h, so that the product sequence will become 0. So, yun yung mangyayari sa multiplication natin. Okay? Then the fourth one. Okay, so yun nga, observe the table that the two sequences, okay, and h of negative 6 minus k and xk, ito, do not have any overlapping non-zero terms. Yan yung tatandaan yung term na gagamitin natin mamaya. Overlapping non-zero terms. Okay? So, therefore, kapag wala silang overlapping non-zero terms, that means the product sequence, okay, is then 0 for all values of k. So, lahat ng values of k ngayon, okay, would be, lahat ng values of the product sequence would then be 0. And that thing, okay, the possibility of your all values of product sequences of the product sequence V NO of K becoming all of them 0 for all case, okay, becoming all of them 0 for all case is possible if both x and h have finite lengths. Ibig sabihin, kapag ang x ninyo at saka ang h ninyo are both finite duration signal, yung possibility that this product sequence will become 0 for all case is likely to happen. Okay, mangyayari at mangyayari yan. So, kailan siya mangyayari? Ito yun. If in the instance na yung shift, if the shift, okay, if the shift NO, okay, produces overlapping, saan tama yung spelling ko? Overlapping. non-overlapping, non-zero terms for the shifted H, okay, and xk, then ito yung mangyayari. Pag shinit nyo si hn, o si h, okay, pag finold at shinit nyo siya, okay, and it turns out that that shift, okay, produces non-overlapping non-zero terms. Ibig sabihin, yung mga non-zero terms nung dalawa yung sequence are not overlapping. Okay, then ito yung mangyayari. The product sequence will become zero. So ano bang significance kapag yung product sequence yung zero? Okay. It means kasi pagdating sa summation, kasi the fourth step is to sum up the values of the product sequence. Okay, isa-sum up kasi natin yung values ng product sequence niyo. So ano mangyayari doon? Pagka nangyari na ang product sequence niyo ay zero, if this turns out to be if turns out that if all VNO case equals 0 for all case, okay, then yung magiging sum nila, okay, the sum, which actually magiging y of n0. That's actually the value of your that's actually one of your sample values that you are looking for. Isa to sa mga sample values na hinahanap nyo. Okay, so that would be the sum eh. Pagka inad nyo kasi yung sample values na to, yung product sequence na to, okay, yung sum niyan, isa sa mga sample values na hinahanap niyo. So therefore, yung magiging sum na yan, magiging equal din sa 0. So say for example, katulad sa case na to, okay, since yung product sequence nyo, okay, since the product sequence here are all 0, okay, since the product sequence are all 0, pag inad nyo lahat yan, okay, magsasama pa yan sa 0. Eh yung sum na yan is actually equal to y of negative 6. Okay? So again, y of n0, okay, equals the sum of x of k, h of n0 minus k, okay, for k equals negative infinity up to positive infinity. Ito yung product, itong product na to, yan yung v of nyo, v of n0 ninyo. So ngayon, pag inad ko yan, at walang lumabas na sum yan, therefore, yung signal value at this particular shift will also become 0. Okay? So here, in this case, since ang NO natin is negative 6, so we're looking for y of negative 6 actually, which is the sum of v negative 6, okay, of k, for k equals negative infinity up to positive infinity. Which again, ito, lumalabas, 0 siya. So therefore, yung y of negative 6 natin, 0. Okay? So, ayan. So we find that y of negative 6 is 0, as indicated in this table. Ngayon, uulitin natin yung actually, folding, shifting, multiplication, summation. Uulitin natin tong apat na proseso na to. Although, syempre, hindi natin ulitin yung folding kasi na-fold na naman natin siya. Okay? So, ang gagawin natin is yung shift natin, i-adjust na lang natin. Okay? Galing sa negative 6, then we will have to adjust it to negative 5. Because, again, it would not make sense kung i-adjust pa natin siya sa negative 7, for example. Kasi nga, kung wala nga tayong nakitang overlapping non-zero values dito at saka dito, pag ito, nilayo nyo pa, okay, by having the shift to be negative 7, okay, kasi pag ginawa nyo negative 7 yan, gagalaw pa ng pakaliwa lalo yan. Kasi this shift is for negative 6 eh. So kapag mas negative pa yung i-shift nyo sa kanila, mas kaliwa pa yung galaw niya. Okay, so it would make sense na i-shift natin siya with less negative shift. So n0 equals negative 5, i-shift natin siya para mag-shift siya sa kanan. Okay, so ulitin natin yun. Okay, so in this case, para mas madali din yung discussion. Okay, dahil nakita niyo naman na yung sense nung algorithm. Okay, ano yung mangyayari or mga possibilities of what will happen for a finite duration signal. Once we do the shift, maghahanap din tayo ng shift that produces overlapping non-zero values for h and k. So maghahanap tayo ng shift na meron tayong mamumultiply so that the product sequence is not entirely zero. Okay, so ito yun. In general, we seek the amount of shift NO that will cause the sequences h and k to have overlapping non-zero terms. Yan. So kapag ka if h and k have overlapping non-zero terms, this would mean that your VNO, the product sequence, the product sequence may have non-zero values, and therefore that would lead to your sample value, or sample sequence to have non-zero to be or maybe so your y of n 0, ayan, maybe non-zero. Yan. Okay? So yun ang hahanapin natin. We would try to seek the amount of shift NO that will cause the sequences h and k to have overlapping non-zero terms. Kasi at that particular point, that means that your product sequence would have or may have non-zero values. And again, emphasize ko lang na may, kasi baka mamaya lagi nyo sabihin na okay. May kasi baka mamaya naman kasi even if they have overlapping non-zero terms, baka naman yung mga products talaga nila magko-cause na maging zero siya. O kaya okay. O kaya meron ngang mga terms yung product sequence niyo, pero pag in-add nyo, magli-lead pa rin sa zero to. So that is why yung y of n0 nyo may also be non-zero. Okay, so emphasize lang natin yun kasi baka mamaya yung mga expectations natin Okay, so again, even if you have kaya may at saka may ang ginagamit nating mga terms dito. Okay. But still, ang hinahanap natin lagi is the amount of shift that would have this h and k to have overlapping non-zero terms so that we can multiply non-zero signal values and therefore produce terms for your product sequence to be non-zero, at baka sakaling meron tayong may add so that magiging non-zero din yung output natin. Okay, and it would also be you could also imagine that the amount of shift, the amount of shift that you would be doing this is actually also finite. Ibig sabihin yung number of shifts na gagawin nyo to is also finite. Kasi it's simply because kung titingnan niyo tong kung titingnan niyo tong table at kung imagine niyo kung paano siya magpo-progress by actually by actually doing the shifts for n0 equals -6, n0 equals -5, n0 equals -4, and so on. May imagine niyo na there will only be a finite amount of shift, that will result to h and x having overlapping non-zero terms. Okay, so since yung length ng x ninyo, yung length ng h at saka ng x ninyo are both finite. Okay, you can just imagine na yung number of shifts nito would also result in a finite amount of shift. Okay, in fact, kung titingnan niyo mabuti to, okay, kung obserbahan niyo to, since dun sa amount of shift na -6, okay, wala na tayong nakitang overlapping, there's no overlapping non-zero terms. Okay, di what more kung i-shift ko siya for -7, -8, -9, -10, and so on. Okay, so in that case, we can conclude actually that at least at this interval, for n between -infinity hanggang up to -6, there will be no overlapping non-zero terms. Yan. There will be no overlapping non-zero terms. Okay? So therefore, kung ganyan yung case, we can conclude that from negative infinity up to -6, then we can consider that your y of n is 0. Your output sequence is 0 for this interval. Okay? So there. Now, if you continue on, actually even for n equals -5, wala pa rin kayong makikitang non-overlapping terms. Wala pa rin kayong makikitang overlapping terms, sorry. There's still no overlapping terms. Okay? So, there is still no overlapping non-zero terms. Ayan. So kung wala pa rin siyang overlapping non-zero terms, that would mean that the sample value or the output sequence would still have a value of 0. Okay? Now, for n equals 4, ito yung scenario. Okay, for n equals 4, ayun. Makakakita tayo ng first first overlapping non-zero terms natin. Okay? Wherein yung sample na 3 ni h at saka yung sample na 3 ni x, magtatagpo sila. So that if you form the product sequence, if you multiply these two sequences, okay, you would have the following values. 0 siya at this time indices. Now at k equals -2, okay, at k equals -2, meron siyang value na 9. Okay? And then for k greater than -2 or for k higher than -2, 0 ulit siya. Okay? But nevertheless, hindi natin concern yung mga zeros na yun. Okay? But what we will do after that, okay, is i-add natin yung mga values nila, yung 0 plus 0 plus 0 and so on. Okay? The important thing is that makakabuo tayo ng magkakaroon tayo ng non-zero sum. Okay, which is now 9. Okay? Now, since ang amount of shift na in-employ nyo dito at this step is -4, okay, this 9 here actually turns out to be the value of y of -4. Okay? So, recall lang natin ang value nung y of n niyo, okay? Ang mga signal values ng y of n niyo na na-obtain natin so far is 0 siya. Okay? This is for n between -infinity up to -5. Okay, yan yung nakuha natin. 0. Lahat yun. 0 yan. Okay? Now, when n becomes -4, okay, makakakuha tayo ngayon ng 9 as a value. Okay? So, ayun. So, next, we proceed with n equals -3 as the shift. So, in that case, dalawa na yung overlapping non-zero terms sila. Okay? So, in this case, your product sequence would then be 0 dito. Okay? Tapos meron siyang positive 3 when k equals -2. When k equals -1, that is -3. Tapos 0 ulit siya. Okay? Which again, i-add natin lahat ng values ng product sequence nyo. And it turns out na magiging 0 siya. Okay? Ito yung sinasabi ko kanina. Hindi ibig sabihin na meron kayong product sequence na non-zero. Magkakaroon na kayo ng non-zero na y. Okay? That is because baka mag-add up kasi sa 0 yung mga terms ng product sequence niyo. Okay? So, but in any case, itong value kasi ito na 0 is considered to be still within the range of or within the interval of y. Kasi meron na siyang katabing non-zero term. Okay, may nauna na sa kanyang non-zero term. Okay, at unless ang pagkatapos itong 0 na to, okay, puro 0 na ulit. Okay, then, this is considered to be parang hindi na part ng signal niyo. Okay, unless kung ang mga kasunod yan ay puro 0 na. So, pero kapag ang kasunod nito is non-zero ulit, then this is part of this is part of the signal or part of the output sequence. Okay? So, now, so far, again, ano nakuha natin? Okay? Is, again, 0 siya. Okay? For negative infinity, up to negative 5. Okay? Tapos nakakuha tayo ng value na 9 for n equals negative 4. Tapos nakakuha tayo ng value na 0 for n equals negative 3. Okay. Now, I want you to continue on yung implementation ng algorithm niya. Okay? For n equals negative 2. Okay? So, for n equals negative 1, 0, 1, and 2. Ayan, sinabay-sabay ko na. So, ito yung para sa negative 1, ito yung para sa 0, ito yung para sa 1, ito yung para sa 2. Okay? So, ito yung mga product sequences natin. Yan. And then, pag inad nyo yan, okay, you would have this as the values for your output response. Okay? So, ito yung mga values na yun. 8, 9, 12, and 8. And then, for the rest of for n equals 3, 4, and 5. Kung titingnan natin yung n equals 3 dito, ito. This is for n equals 3, shift na equal to 3. This is shift na equal to 2. 4, I mean. Again, baka pasin nyo ngayon positive yung at this point, positive na yung shift. Okay, so if the shift is positive, ito yung original na h ninyo. Okay, pag positive na yung shift, dapat nasa kanan na nung original na h of negative k, yung shifted version. So, ito na yun. Say for example, for h equals negative 3, ito na siya. So, delayed na siya with respect dito. Okay, this is h of 3 minus k. So again, pag positive to, you tend to move the signal values to the right of the original signal values. So delayed na siya. Okay? So now, for n equals 3, 4, and 5, we notice na pagdating sa 5, isa na lang yung okay, isa na lang yung terms that are non-zero terms that are overlapping for h and k. Okay? So that pagdating ng 6, wala na. Okay, wala nang overlapping terms. So ito yung sinasabi ko na finite lang yung number of times na magkakaroon kayo ng overlapping non-zero terms. Okay, so there will be finite number of shifts that produces overlapping non-zero terms. Okay? And this applies for finite duration x and finite duration h. Okay? Kasi you can imagine na na after ng y of 6, say for example for the shifts 7, 8, 9, 10, 11, and so on, wala na talaga kayong makikitang overlapping non-zero terms. So that you can consider that from 6, okay, up until positive infinity, again, yung magiging value ng signal niyo is 0. Kasi nga wala nang overlapping non-zero terms eh. So 0 yan because no overlapping non-zero terms starting from 6. Okay? So, we say na from negative infinity to, mali pala to. From negative infinity to negative 5, okay? And from 6 to positive infinity, Okay? Yung y of n niyo is 0. So, saan lang merong non-zero yung y of n niyo? Yung y of n niyo ngayon is defined from negative 4, n equals negative 4 hanggang positive 5. So, from negative 4 to positive 5, ito yung magiging sequence niyo. So, ito. From n between negative 4 to positive 5, ito yung magiging sequence yn niyo. Okay? So, ito yung the signal value for n equals negative 4, negative 3, negative 2, negative 1, for n equals 0. Kaya nandun yung marker natin. 1, 2, 3, 4, and 5. Okay? So, yan yung magiging convolution. Ito ngayon, this one, is ito yung mga tawag natin dyan. This is the response of the system Hn to Xn. Okay? Or pwede rin ito yung output sequence produced or generated by feeding Hn with Xn. Or feeding your system. Kasi yung Hn tries to describe the system or tries to represent the system. So, pag nilagay ko yung Hn dito, it means feeding the system. Okay? Or response of the system Hn. Okay? So, ayun. And Xn here is the input signal. Okay? So, or simply, we can refer to the sequence Yn as the convolution sum. Okay? So, the sequence Yn here is the convolution sum of the sequences Xn and Hn. Okay? So, in particular, if Xn is an input, okay, to an LTI system whose impulse response is Hn, then Yn would be the system's response. Okay? So, again, sinasabi natin that we recall, no? We recall that ano yung nx tsaka nh? Layo na kasi. Ayun. So, ang nh natin is 5, ang nx natin ay 6. Okay, balikin natin siya dito. Okay, so we recall that our nh parang nakalimutan ko yung kinuha natin kanina. Ayun, ito na pala. Ang nh natin is 5. This is the length of h. Okay, while this is the length of x. Okay. Length means the number of terms, okay, or the number of sample values. Length of x. Okay. So, since both of our signals, both of the input signals that we have considered here are of finite duration. Okay? So, dahil ang kinonsider nating input or ang kinonsider nating sequences in this example are both finite duration. Okay? It turns out that the convolution sum of two finite duration signals is also a finite duration signal. Okay? So kung finite duration yung sequence xn niyo at saka hn niyo. Okay? Which in this case nga 6 yung length ng x at saka 5 yung length ng h. Okay? It turns out na yung yn niyo will also have a finite length. Okay? And there is a way for us to predict. Okay? There is a way for us to predict yung length of y. Given na alam natin, okay, yung length ng x at saka yung length ng h. So that that formula that predicts that is given in this one. So the length of y is the sum of the lengths of x at saka h then minus 1. So in this case, the length of x is 6 then plus 5, okay? Then minus 1 natin as part ng formula. So this is 10. So mabibilang natin na yung y ninyo has 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So yun. So those would be that is how we we implement the convolution sum. Okay? algorithm. Okay, so again, kung titingnan niyo mabuti yung steps. Okay? Consistent naman siya with with equation 3. Okay? The algorithm is actually very consistent with equation 3. Okay, which is why kailangan natin tandaan talaga yung apat na steps. Okay, in the implementation of the convolution sum. Okay, so folding, shifting, multiplication, and summation. Okay, sorry. So, ayan. So, now, ito lang, additional para mga additional facts lang about the convolution sum. Okay? Especially in the context ng discrete time signals. Okay? Una, gamitin lang natin yung mga input signal natin. Okay, so ano yung input signal natin? So these are parang fun facts about ewan ko kung fun sa inyo to, pero this might although I don't recommend din you computing the convolution sum using this way. Okay? Since naman kayo, naka-online naman tayo, wala namang masama kung i-compute nyo yung convolution sum using MATLAB or using Excel. I really don't recommend computing the convolution sum this way. Okay? Tinuturo ko lang to nung time ng face to face because pagka-quiz, syempre kailangan mo ng mabilisang way to actually compute the convolution sum. Okay. Ito. Una-una, i-assume natin na itong mga to, okay, are actually these vectors. Okay, let's assume that these are vectors. These vectors are coefficients. Okay, coefficients of a polynomial. O polynomials, kasi dalawa sila. So, dalawang polynomial ma-define natin. So, assume that these vectors are coefficients of polynomials. So, what I mean is this one. Say, the polynomial P, okay, using H as its coefficient in terms of X or as a function of X, would be, ito yung pinakadulong, ito yung constant ng polynomial. Ito yung dulo na to, yun yung constant ng hindi, since meron ka palang meron ka palang n equals 0. Okay, n equals 0. So, ganito pala. Yung n equals 0, yun yung exponent niya. Okay, nung x. Okay. Say for example ito, this would be this would be given as 0, 1, 2. Okay. So, this would be negative x square. Okay. Plus x. Okay. Plus 2 plus x raised to negative 1, okay, plus 3x raised to negative 2. Okay, that's for the polynomial in terms of the h as coefficients. While for x, okay, p of x as a function of x. Okay, so this would be, kung n equals 0 to, it's 1, 2, 3. So this is x cubed plus 3x squared, okay, plus 2x plus 1 minus x raised to negative 1 plus 3x raised to negative 2. Okay? So again, yung mga coefficients na to, okay, the coefficients of your polynomials are based on these vectors. Tapos yung yung n or the time index are actually exponents of the of the variable multiplied to that coefficient. So actually, itong representation na to, later on na makikita nyo rin inaaral din actually sa sa ibang sa ibang fields of study, like for example sa encryption. sa data communications. Okay. Actually represents both both the signal values and the time index. So dito kasi pinapakita lang natin yung signal values lang. Tapos yung time index pinapakita natin in another way. Dito ginagawa natin tong parang formula na kagad. Okay? So both signal values and the time indices or time index are indicated. So again, yung representation na yan nung vector as a polynomial is something na ginagamit talaga. Are indicated. Now, ito yung point ko. I want to produce the product the product of the polynomials p times h, p of h, ph times px. So, i-multiply natin siya. Okay. So, para ma-multiply natin siya, syempre yun, multiply siya. Ang gagawin natin, first is to actually write the polynomials. So, this is x cubed plus 3x squared plus 2x plus 1 minus x raised to negative 1 plus 3x raised to negative 2. Tapos, ito, yung siya naman, kung paano kayo mag-multiply ng polynomials nung high school kayo. Di ba, ina-arrange siya on a vertical manner. Pinag-grupo nyo on a column yung mga magkakapareho yung exponent na variable. Say, this becomes negative x squared plus x plus 2 plus x raised to negative 1 plus 3x raised to negative 2. So, i-multiply natin yan. Okay? I-multiply natin siya. Okay. Tingnan niyo yung magiging sagot. Okay. First, so ito, multiply dito, no? So, you would have 9x raised to negative 4 plus negative 3x raised to negative 3. Okay. Plus 3x raised to negative 2. Okay. Plus 2 x raised to negative 1 plus 9x raised to 0. So, 9 na lang yan. Okay. Then, plus 3x plus 3x. Okay. So, that's 4, this 1. Okay. Next. Ito. This is positive 3 x raised to negative 3. So, pwede kong i-add to kasi pareho siya ng exponent. Okay? Minus x raised to negative 2. Okay? Actually, yun yung value kung bakit nyo pinagsasama-sama sa isang column yung para kapag multiply nyo siya, magkakasama rin yung products nila magkakasama din yung mga magkakaparehong exponent sa isang column. So, you'll have plus x raised to negative 1, then plus 2, then plus 3x, okay, and then x squared. Okay, so let me just work on this offline para hindi naman tumagal tong recording natin. Okay, so tapos ko na siyang i-multiply. Okay, meron lang akong ginawang correction dito. Ito, parang 1, 2, 3, 4. So, 1, 2, 3, 4. Ito. 6 pala product niya. Okay, 6 x raised to negative 1. So, yun, kinirect lang natin. Okay. Ngayon, niligay ko dito yung yung part ng table which shows the product sequence for n equals negative 1, 0, 1, and 2. Okay, pero pansinin niyo ito sa lahat ng ituturo kong Okay, ito yung gusto kong i-point. If you actually try to notice yung values nito. Okay? Yan, yung values niyan, for example. Again, take note that yung exponent nung x raised to negative 1 here, itong exponent na negative 1, actually depicts the time index n equals negative 1. Okay? Tandaan natin yan. Kasi yun yung ginawa natin yan dito convention dito Okay? So, yung x raised to negative 1, yung exponent nun, okay, actually depicts the time index negative 1. Now, what I'm trying to point out here is if you actually look at the product sequence when n equals -1, okay, the terms of the sequence or the terms of the product sequence would be, na non-zero would be 3, -2, 1, and 6. 3, -2, 1, and 6. Diba? So, may konting magic dito, no? Okay? So, anong ibig sabihin nun? Sa standpoint ng multiplication ng polynomials, syempre, pagkatapos kong i-multiply lahat ng polynomials yan, i-add ko yan. So, that would become 6 plus 1, 7 plus minus 2, so that's 5 plus 3. That would be 8x raised to -1. Okay? So, yung magiging sum nun, nung ano to, is 8x raised to -1. Kung titingnan yung operation na ginawa natin dito, i-add natin to eh. That's 3 plus -2 plus 1 plus 6. That should sum up to positive 8. And that's the value for your output sequence na y of -1. Again, yung 1 dito pertains to the time index n equals -1. So, ano yung point ko? Okay? Ano yung point ko? Discrete time convolution sum is actually analogous to polynomial multiplication. Okay? Kaya actually, it's actually analogous to polynomial multiplication. Okay, so the algorithm that fold, shift, multiply and sum is actually an algorithm. Okay, that is used also in multiplying polynomials. Okay? And this is kung pag-isipan niyo pa mabuti at naturuan kayo ng iba pang technique sa pag-multiply ng polynomials nung kayo ay nasa high school. Say for example, if you have to multiply x plus 1, multiply 2x plus 1. Halimbawa lang to para medyo simple lang yung problem. Eh, ang ginagawa nyo yung table. Like, nilalagay nyo yung coefficients nung isang polynomial nyo horizontally, yung isa naman vertically. So, say for example, for x plus 1, you'll have it as 1 and 1 here. Tapos ito naman, vertically, so 1 and 1 here. Tapos, gumagawa kayo ng multiplication, table dito, such as magiging 1 times 1 is 1, 1 times 1 here is 1, 1 times 1 here is 1, then 1 times 1 here is 1. Tapos, ginagawa nyo to. Yung diagonal addition. So, yung first diagonal sum nyo is 1. Tapos, yung second diagonal sum nyo, ito, okay, is 1 plus 1. So, that becomes 2. Okay. Then, yung last diagonal sum nyo, okay, is 1. Okay. You'll see na if you actually put in yung x at saka yung constant dito, and yung x at saka yung constant dito, you'll observe na yung magiging product dito, okay, is x squared. Tapos ang coefficient niya ito. So that would mean that yung first term ng product nito is x squared. Okay? While yung product na x at saka k dito, actually x at saka constant actually pertains to the product x. Okay? Tapos yung coefficient niya dito, yung product ng coefficient na 1. So ito, magkakaroon dito ng x na variable. So, kailangan mo siyang i-add diagonally. So, x plus x, that is 2. So, yung magiging second term mo dito is 2x. Okay? And, finally, this is constant times constant. So, walang variable to. Okay? But still, ito yung 1 na coefficient. Ito yung 1 times 1 dito actually. So, yung magiging last term ninyo is 1. So, yung x plus 1 times x plus 1 is x squared plus 2x plus 1. Okay? Pero ginawa ko siya on a table. So, i-apply nyo yan actually dito para ma-eliminate din yung pangailangan nyo to actually write off x's here and their exponents. And you'll see that you'll have the same results of the signal values for your y of n using this table. Okay? So yan. Yung technique na turo ko sa mga students kapag pagka page 3 kasi that's the only way na makapag-produce sila ng values kapag kasi kapag yung actual algorithm ng aabutin sila ng siyam-siyam sa pagka-table pa lang. Okay, so that is why. Okay, that's why tinuturo ko yan sa Pero sa inyo, you don't really need to use that as part of your solution sa quiz. Kasi unang-una, pwede niyo naman tong i-MATLAB eh. Okay. May mas madaling solution nito sa MATLAB which naka-indicate din dun sa ibang parts ng mga example niyo. Okay? Naka-indicate naman siya dun sa ibang parts ng example. Okay. So yan, meron namang ito. May example dito na Hindi ko ginawa yung MATLAB solution para sa convolution sum ng example 2 ninyo. Okay? Pero ginawa ko siya sa example 3 para makita niyo yung effect makita niyo siya makita niyo yung effect ng mga step-by-step process nung convolution sum and yung substitution actually. Okay? By the way, ang example 3 kasi deals with convolution sum for 2 infinite duration sequences. So, kung ang example 2 dealt with 2 finite duration sequences, okay? Example 3 would deal with 2 infinite duration sequences. So, yun yung pag-uusapan natin for example 3, which I would put na lang on another part of on another recorded lecture. Okay? So, ayun.